So, to really understand the fundamentals of ECG, you must first understand the electrical activity of the heart, right? So, let's talk few words about the electrical activity in the myocardial cells. Here I draw 3 ventricular myocardial cells, and we see what is the electrical activity normally in these cells. Let's suppose this is first myocardial cells, ventricular myocardial, this is second cell, and this is the third cell, right? And we see how the electrical activity goes through that, right? Then we will discuss how that electrical activity can be eventually translated into ECG pattern. Fine? Let's suppose that right now these myocardial cells are not stimulated, they are unstimulated. There is no action potential passing through them. Is that right? So we say these myocardial cells are resting. If this cell is electrically resting, right, it must have resting membrane potential. Now what is resting membrane potential? Resting membrane potential is the electrical voltage difference between the inside of the membrane and outside of the membrane. Normally, resting cells of the ventricular myocardium are electrically negative inside, right? For example, the resting membrane potential is minus 90 millivolt in a resting cell. When I say this myocardial cell has minus 90 millivolt resting membrane potential, I mean that in the resting condition, this myocardial cell has its membrane internally polarized negatively, right? Now, what really happens that as soon as the cell is stimulated, right? Now, when there is appropriate stimulation to a myocardial cell, suppose ventricular myocardial cell, if there is appropriate stimulation, what will happen? That its resting membrane potential will reach to the threshold, right? As I said, resting membrane potential is minus 90 millivolt, is that right? And this is minus 90. If we stimulate the cell, then some cations will come in, some positive charges will come in. Let's suppose that we bring some sodium or calcium ions in. If we bring some electropositive ions in, what will happen? That this electropositivity which is coming into cell after the stimulation, this will take the resting membrane potential towards less negative value, because these positive charges will neutralize the electronegativity. Is that right? To some extent. So what really happens, as soon as positive charges are coming in, resting membrane potential is becoming less negative. For example, it become minus 80 and then it become minus 70 millivolt, right? Now, as soon as resting membrane potential from minus 90 millivolt, right, it moves towards the threshold potential. And let's suppose in this cell, threshold potential is minus 70, right? Threshold potential is a potential at which membrane of this cell will suddenly open voltage gated sodium channels. These are voltage gated sodium channels, and right now these channels are off. These channels are not working. But as soon as you stimulate the cell and some cations are coming in, resting membrane potential start moving towards threshold. As soon as it touches the threshold, voltage gated sodium channels open up. As soon as voltage gated sodium channels open in the cell membrane, lot of sodium comes in. Lot of sodium is coming in. Why? Because normally sodium is more outside the cell. Is that right? And normally cell is electrically negative inside. So as soon as the resting membrane potential goes to the threshold voltage, right, then voltage sensitive sodium channels open, a lot of sodium comes in. This sodium, as it is rapidly coming into cell, is progressively neutralizing the electronegativity, and this threshold potential, which was minus 70, it will become minus 60, minus 50, minus 40, and eventually it will become 0. It means as more and more sodium is coming in, this membrane potential is progressively going towards positive value. Initially it is losing the electronegativity, and eventually it may become positive. For example, it is minus 60, minus 50, 40, 30, 20, minus 10, 0, and even it may become plus 10. So what has happened? That once the voltage gated sodium channels open, lot of sodiums come in, this movement of sodium inside, right, neutralizes the resting membrane potential and take it towards electropositivity. And we say the membrane, which was previously negatively polarized, it has lost its negative polarity. What has happened? On appropriate stimulation, a lot of cations came in, and these incoming cations neutralize the electronegativity of the membrane. So inside of the membrane, right, which was initially negatively polarized, it has lost its negative polarity. Or we simply say membrane is depolarized. When membrane loses its negative polarity, we say membrane is, yes please, membrane is depolarized. So this event is called depolarization current. Once depolarizing current is produced and we say cell is depolarized, what is the next electrical event? Next event is the depolarization sensitive depolarization sensitive calcium channels and potassium channel both start opening. Right? Now, these red channels are calcium channels and these green channels are potassium channels, right? And you must be knowing that in a normal healthy cell, right, its normal healthy cell is very, very rich in potassium. Intracellular potassium is normally more as compared to the extracellular potassium. And extracellular calcium is more normally as compared to intracellular calcium. Now what really happens? Listen, you stimulated the cell underwent lot of sodium influx, that led to phenomenon of depolarization, then depolarization sensitive calcium channel, then potassium channels opened. When potassium channels opened, I told you inside of the cell is very rich in potassium. So potassium will start leaking outward. What is happening? Potassium will start moving outward. There is efflux of potassium. As soon as efflux of the potassium start, it means cells start losing cations. Cells start losing cation. It comes towards the electronegativity. But as soon as it is around 0 voltage, calcium channels also open. So for some time, for a very short time, potassium keep on moving out, and as calcium channels are open, so calcium keep on moving in. It means for a brief duration, potassium as positive charges are lost and calcium as positive charges are gained to the inside of the cell. So it means for a brief duration, cations are lost as potassium as well as cations are gained as calcium. So loss and gain of calcium balances the potential, right? What really happens that as potassium is being lost, at the same time calcium is being gained, so there is no net change in potential. But as time passes by, calcium channels close. As time is passing by, calcium channels start closing. But as time passes by, potassium channels become more and more active. So what is the result? That by this time, no more calcium is coming in. But because potassium channels have become more active, so potassium losses become very, very heavy. There is a heavy potassium efflux. And as more and more potassium is going out, it means more and more positive charges are going out. It means cell will again start developing electronegativity because cell is losing the positive potassium. So when potassium keep on moving out, what really happens? That cells, due to loss of positively charged potassium, become progressively electronegative, and potassium is progressively being lost. Potassium is being lost until membrane potential again becomes at which value? Resting membrane potential value, that is minus 90 millivolt. Is that right? So what happened during this time? What happens really? That electrically membrane has come back to its negative polarization. If membrane has come back to its negative polarization, it means membrane is repolarized. Due to potassium efflux, membrane has gone to the phenomenon of repolarization. Let's revise it again. What really happens? This was a resting myocardial cell. It was having resting membrane potential of minus 90 millivolt. Is that right? When it was appropriately stimulated, some cations trickled in, entered in. These cations took the resting membrane potential at threshold potential. At threshold potential, voltage gated sodium channels open. Lot of sodium comes in and then potential goes towards it loses all the electronegativity and goes towards the positive side. This phenomenon is called, membrane is undergoing which phenomenon? Depolarization. Membrane is depolarized. After depolarization, in ventricular and atrial cells, repolarization process start. In repolarization process, initially potassium goes out, but very soon calcium start coming in. For a brief time, potassium is going out, but at the same time calcium is coming in, so cations are lost as well as cations are gained. So there is no voltage difference. So we say that electrical potential is showing plateau phase. But eventually calcium channels shut down and potassium channels become progressively more open. So lot of potassium leaks out, and due to heavy losses of positive ions, right, membrane become progressively electronegative inside, and potassium keep on going out until the membrane voltage goes back to its resting negatively polarized state. So we say that there is membrane has gone under the phenomenon of repolarization. So these two processes together, they are called depolarization and repolarization. Is that right? So by stimulation, we say this cell number 1 has undergone process of depolarization, and after the depolarization, it has undergone repolarization. Is that right? Once this cell went under depolarization, once this cell it was undergoing depolarization due to sodium influx, right? The sodium which was coming to this cell, some of this sodium through gap junctions, these are very special connections between the adjacent myocardial cells. Adjacent myocardial cells, neighboring myocardial cells have electrical windows. So what happens? When one cell undergoes depolarization, the cations which have come into the cell, some of these cations trickle to the next cell. From here they go to the next cell. When cations from the first stimulated cell trickle into next cell, what really happens? Then resting membrane potential of the next cell will reach up to, yes please, reach up to threshold. And then what will happen? Voltage gated sodium channels will open into this. Then same thing will happen for short time. Voltage gated calcium and potassium channels will be open simultaneously. Eventually calcium channels stop, but potassium channel keep on working, and losses of potassium eventually take the membrane potential back to its resting situation. So it means depolarization of one cell led to the depolarization of second cell. And when second cell is depolarized, when second cell gains a lot of cations, it trickles the cations into third cell, and then third cell undergoes the process of depolarization and repolarization. It means that this fluctuating potential of the membrane, right, the membrane fluctuates from resting membrane potential to depolarization, and then it fluctuates back to repolarization. This depolarization and repolarization, they are moving in the cell membranes. Because depolarization and repolarization are moving, so this fluctuation, total electrical fluctuation of depolarization and repolarization, because it is mobile, it is called action potential. Is that right? Let me write it more clearly. that there is, yes, resting membrane potential, and with proper stimulation, there is stimulation. Resting membrane potential will lead to the membrane to, yes please, depolarization. Then depolarization will stimulate initially calcium and potassium channels, but eventually potassium channels become very active and a lot of potassium goes out, and that leads to repolarization. And as depolarization and repolarization are moving on the membrane, so both of them together, they are called action, yes please, action potential. Is that right? So in next discussion, when I say that cells are undergoing depolarization, it means cell is gaining cations, usually sodium. In case of atrial and ventricular cells, they undergo, during depolarization, they gain sodium cations, right? And if there is, special point, if there is depolarization of SA node and AV node, remember, depolarization of SA node and AV node is not sodium dependent, that is calcium dependent. So it means when I say that atrial tissue or ventricular tissue is undergoing depolarization, it means those tissues are gaining sodium. And if I say SA node and AV node are depolarizing, it means they are gaining calcium. But anyway, depolarization is whenever cell is appropriately stimulated and a lot of sodium or calcium come in and depolarizes the cell. But whenever cell is depolarized, it is followed by which activity? Repolarization. And this depolarization in one cell stimulates the next cell through the gap junctions. So next cell become depolarized, and second cell will depolarize the third cell, and third cell will depolarize the next cell. So in this way, in the heart, because every cell has electrical windows or gap junctions with the next cell, so electrical stimulation of one cell can lead to the electrical stimulation of the next cell. Am I clear? If this basic concept is clear, now we'll talk about that little bit more in detail, right? Eventually, what we have to understand today, we have to understand that how electrical activity of the heart can eventually be presented as ECG pattern. Is that right? Now, we develop some more basic concepts.